So where we left off was needing to fill in the parse line from file function, which is being called each iteration through the file, one line at a time. And what may make sense here is just to, in a comment, let's just kind of indicate what the data looks like with regards to each line. So it's DPS, address, and port. So we've got that reference for us. We could then, I would suggest, let's go ahead and set up a stack var for each of those parameters. The DPS being a device, the address being a string or a char array, the 255 length to support theoretical max length of a fully qualified DNS, and then the last one would be an integer for the port. And essentially what we need to do is we need to take each one of these elements and populate that stack var with them. So this CSV file data, CSV standing for comma separated value, I've got value, comma, value, comma, value, comma, so on and so on and so on. Interestingly enough, if we take a look at Snappy, the duet parse command param function is a fully compliant CSV parsing function, because in the duet standard, the Snappy standard from the command API syntax formatting, if there are multiple parameters returned in a single command, they are comma separated. So we actually can leverage this duet parse command parameter anytime we're dealing with CSV data, if it being, even if it's not coming from a duet device or a Snappy device in a command, we can actually leverage it from parsing CSV data out of a file. So in that case, let's go ahead and add in a stack var, another char for my iparam. We can leverage duet max param length constant like we've done previously. We can then set my iparam equal to duet parse command param, and we will be parsing a line. And it is destructive, so at this point I have my DPS value, because that is the first comma separated value is the DPS. So I can then go ahead and let's just take a peek in here. So if we go take a look at what the dev data type is, we actually will see that the dev data type is a structure with an integer number, integer port, integer system. Cool. So we have a string value here, so my iparam at this point is the DPS value, so I should be able to do iDevice dot number equal to ATOI iparam so that would give me this. But actually what I want to do is I kind of want to nibble through this thing. So I want to get this first, then the port, then the system. So instead of just going arbitrarily to the iparam, I'm actually going to remove from iparam everything up to the first colon, starting at the first location. So that will then cleave off the D, leaving P and S. I can then set my iDevice.port, again equal to ATOI, very similar. Spelling matters. And it's pretty much the same thing. Now I want to get the P component, so I will just do another remove string. Now I'm going to get the P and leave the S. And to finish this off, my then iDevice.system is just going to be ATOI, integer to ASCII, whatever's left, I param. Something like that. And because we want to support multiple devices here, let's go ahead and evaluate what device we are actually reading in. So we'll do a select active, and we can take a look at iDevice.port. And what we're going to do is we then can go and basically look at each of our device, our IP devices, and see which one this particular line of data is meant for. So if it's port 3 in the file, it'll be port 3 as defined in here, and we're good to go. We can then go ahead and grab address, and that is going to equal to duet. Again, we're going to be doing yet another parse, and we'll be back to parsing a line. Get address, and then finally my iPort will equal to ASCII to integer, and once again one more call to duet parse command param, something like that. And once we've got those two values, we can go ahead and set our parameters that we already have from the include file and carry on. Or can we? So yeah, as it says here, symbol uRoku IP connection is not defined. That is this thing here. It is not defined because we don't define it until our include file, which is a rule that we've already been discussing since P1. That yeah, we can't reference a variable or a constant until that's being defined. Now, sure, we could go ahead and move this include file up to here, or maybe we could move our functions down to here, but things start to get a little discombobulated at that point, where we're starting to veer or make exceptions to some rules that we're kind of establishing with regards to how we want our code to be formatted. And this would all go back to the style guide and and consistency within within an organization with regards to how the code is done. So we have a bit of a problem here in terms of how we actually go about setting these parameters, these variables inside of this include file. Well, when it comes to that rule in terms of what things need to be defined before they're referenced, that only applies to, that doesn't actually apply to functions. So we can create inside of our include file, we can create a function. And we call it, I don't know, set Roku com. Pass in a couple of parameters here. How about a char and an integer. We can then basically copy and paste what we tried to do in our main file. In our include file, Roku, there's no L in Roku. And then in our main file, I can then call that function passing in my parameters. And with any luck, compile it. And yeah, so that works. So that defining something before it's used rule does not apply to functions. So we can leverage that here, adhere to our model that we're developing with regards to the style in terms of what pieces of code go where. And we can then leverage the rules to our advantage. Let's quickly go back to the include file. Yeah, where we call IP client in our include file. Yeah, up here. Best practices, it's always a good idea, as we've discussed, to proactively condition against runtime errors. And at this point, this Roku IP connection and this Roku IP connection, these elements in this structure they were already variables, but they were variables that we were setting in code, in hard code at startup. That data is now coming in from out of band or externally from our code. And if we were to pass invalid data in here, some weird things can start happening with regards to runtime errors and the like. So in order to prevent this, in order to be proactive against that showing up, we can do some simple evaluation here, such as, do we have an address? Is there length in that particular thing? And do we have a port? Do we have a value set in my .port other than 0? So that just conditions against runtime errors, any unnecessary runtime errors. Whenever we have that opportunity, we should take it. It'll just save us time later on in terms of cleaning up that diagnostics thing. Keeping that diagnostics panel nice and clean of unnecessary data. So give that a save. Compile the whole thing. And yeah, there we go. That's the file IO. Just so real quick. So in this walkthrough, we did the file read function, the functionality. That same thing applies with file writing that we didn't do, but as you can see here, there is actually some example code that shows you, and again, you could certainly use this as a template in terms of writing to a file. Notice that this one is an append to file. So the file open process, it's going to be read, writing, appending. So whatever's in there, it's just going to add on to the end, and then it's essentially going to add in one new line to that file each time this is called. So again, from a reference purposes, this append to file function may prove useful with regards to to answer the question, or to start to answer the question of how do you write to a file. So the exercise, this last exercise, is a little more involved. You're going to be creating structures and so on and so forth, reading in file data, and then doing a comparison with the NFC custom event. So I would suggest you start with what we had in the last exercise, or where we ended up at the last exercise, if you did the last exercise, and then carry forward. If you skipped over the last exercise, which we indicated was optional, you're going to be creating structures and iterating through them and responding to the custom event as it is propagated from the touch panel. In the next video, we'll come back and take a look at a solution for that.